Presenting to you 100G Ethernet demo on iWave Zynq MPSoC Development Platform. RDMA technology is widely used to support 100G Ethernet. RoCEv2 is widely used implementation which offloads RDMA stack onto FPGAs to achieve high throughput with minimum CPU utilization, significantly reducing latency by establishing a direct path between memory and network interface card. iWave Zynq MPSoC Development Platform readily serves the purpose of prototyping and evaluating 100G Ethernet solutions through high-speed QSFP28 connector. iWave has successfully demonstrated the capabilities of this platform by implementing a 100G Ethernet solution by integrating Xilinx ERNIC IP. The hardware used for this demo includes the iWave Zynq UltraScale MPSoC platform, Mellanox Connect X5100G NIC, Zynq 1588 PTP Enabled 1G NIC, MTP cable, QSFP28 modules, and Cat6 RJ45 Ethernet cable. Ubuntu 22.04 server PC. In this demo, we are going to demonstrate the raw data transfer and video data pattern transfer from iWave development kit to the server PC. Xilinx ERNIC IP is used to offload RoCEv2 Stack on to FPGA. ERNIC Controller is responsible for carrying out handshaking with all other modules for the data transfer and creates work queue entries followed by ringing doorbells of ERNIC IP. Xilinx UltraScale plus 100G Ethernet subsystem takes care of MAC and physical layers. Data pattern generator is responsible to generate raw data as well as video data pattern. High-level architecture is as shown in image. The implementation is divided among PS and PL blocks present within Zynq MPSoC. Processing system, PS, consists of ARM Cortex-A53-based hard SoC which is used for basic system configuration, control and diagnostics. PS will run Xilinx 100G Ethernet driver provides a high-performance, low-latency 100 gigabits per second data transmission support. ERNIC Controller driver. The driver is responsible to post incoming data to DDR and notify ERNIC IP. Driver is also responsible for efficient doorbell exchange with the user application and ERNIC IP. RDMA core and user space libraries. RDMA core driver, user space libraries will be ported to Zynq UltraScale +19EG platform. Let us start the video streaming over 100G Ethernet demo. Bring up the 1G Ethernet in the iWave 19EG platform using the ifconfig command. Bring up the 1G Ethernet in the server PC using the ifconfig command. Now ping server PC from iWave 19EG platform. Ping iWave 19EG platform from server PC. Bring up the 100G Ethernet in the iWave 19EG platform using the ifconfig command. Bring up the 100G Ethernet in the server PC using the ifconfig command. Now ping server PC from iWave 19EG platform. Ping iWave 19EG platform from server PC. Execute PTP application as master to synchronize board hardware clock with Zynq 1588 NIC hardware clock. Log into iWave 19EG platform over SSH and execute Linux PTP application as slave to synchronize hardware clock. Configure the environmental variables and insert the Xilinx module on the RDMA transmitter side, iWave 19EG platform. Now let us start the data transfer from iWave development kit to the server PC. Transfer the 8 megabits raw data pattern with RDMA write operation on the transmitter side. Transfer size should be specified in KB, and transfer size command line parameter can be configured with from 4 kilobytes up to 8 kilobytes. Now execute the RDMA receiver application. RDMA transmitter transmits raw data pattern until stop request is received. Keyboard key S at receiver side is used as toggle interrupt to stop and start RDMA data transfer. In order to stop RDMA data transfer, press the keyboard key Q on the RDMA receiver side. Last 10 WQE data will be stored in text files in the current folder. Once the stop request is received by RDMA transmitter, throughput and number of WQEs transmitted will be displayed, and again it will wait for the start close request from the RDMA receiver application. Using diff command, compare generated last 10 WQE data stored in file with predefined data file. If there is any difference, it will be displayed on the console. Transfer the 4050 kilobytes video data with RDMA write operation on the transmitter side. Now execute the RDMA receiver application. RDMA transmitter transmits raw data pattern until stop request is received. Keyboard key S at receiver side is used as toggle interrupt to stop and start RDMA data transfer. In order to stop RDMA data transfer, press the keyboard key Q on the RDMA receiver side. For RDMA write operation, the last 10 WQE data will be stored in BMP image files. Once the stop request is received by RDMA transmitter, throughput and number of WQEs transmitted will be displayed, and again it will wait for the start/close request from the RDMA receiver application. Now let us test the RDMA ping using exping command. Execute RDMA transmitter application on board side in server mode. Execute RDMA receiver application, server PC, in client mode. It will show the result of test case as passed.